Okay, so we're moving into the LDP tunneling now. So the first thing that we have to do is on these interfaces I've marked with X, we have to actually enable LDP. So router 2 and router 8 are not running RSVP, they're only running LDP, and that's why they weren't in the previous section where we were defining the label switch paths, which of course were RSVP. We also need to remember that router 1 is out of the TED database because it's running OSPF. And so what we're doing here is we've been asked to make sure that router 8 and router 2, which are only running LDP, can have a full mesh of connections with all the other routers except for router 1. So that's what we've been asked to do. The first step is to go onto router 2 and to enable the LDP on these two interfaces and also MPLS. And reverse. And what I mean by that is we have to go onto router 5 and enable the same interface, which is 5.2, and onto router 6 and enable the same interface, which is 6.2. And on router 8, we need to enable LDP on the interface and MPLS on these interfaces here, and then on router 4 and router 7, we need to do the same thing. And then, to prepare for the MPLS LDP over RSVP tunneling, we need to have LDP on the loopbacks of all of these routers here. Now, they're running RSVP, but on the loopbacks they need to run LDP, because what's going to happen is it's going to be used to build this mesh of connections. Now, strangely, the tunneling that we put on here won't need to be configured on router 2 and router 8, because of course LDP is running and we'll connect them up. And remember that R1 is not included in this. Okay, now it's worth noting obviously that for R2 and R8 LDP is already on, and don't forget LDP will only carry the loopback information, so they're already on in that sense. Okay, so we have a look at router 3 now, and this next process happens to all of the routers here that are running the RSVP. The first thing that we need to do is to turn tunneling on all of the existing RSVP label switch paths. And then if there is a label switch path missing from a full mesh, we need to add it. So here there was no R3 to R4 label switch path, so we're adding one. We're also turning off CSPF, and that just makes this process easier so that the admin groups aren't going to be affecting the paths. And once we've built that full mesh of RSVP paths, then LDP with the tunneling is going to effectively make a full mesh of LDP paths. It's going to include R8 and R2, effectively building targeted LDP paths, and will be fully meshed. The last thing that we've been asked to do here is to hide the PEs within the MPLS zone to outside ping and trace route. So there's two ways to do this. There's no propagate TTL and there's no decrement TTL. They are slightly different. The propagate TTL is going to decrement by 1 as you enter the MPLS cloud and then by 1 as you exit. So basically you can see the egress node, but you can't see the detail of the cloud. However, this is only for RSVP signaled LSPs because it's a special object that's created by the RSVP. No, decrement TTL works on both RSVP and LDP, and it just rewrites the time to live at 255. So it just exits at 255. You can't see any of the detail inside, but obviously you get an unusual TTL value.